Okay, picture this. A visitor, not from our neighborhood, but from a whole other star system, comes blazing through our solar system. And as it swings past our sun, it does something, well, something that just shouldn't be possible, completely baffling scientists. This is the incredible story of 3I Atlas. You know something wild is happening when you get headlines like this one from the New York Post. It's catchy for a reason. But as this thing got cooked by the sun, it just didn't react the way it was supposed to. It seemed to defy the very rules we've written for comets. And that really gets to the core of the mystery, doesn't it? When we see something from so far away act in a way we can't explain, what are we supposed to think? Are we just looking at a really, really weird comet? Or could we be looking at something else? So why all that fuss? Well, 3I Atlas is, only the third interstellar object we have ever seen. Just think about that for a second. Every one of these is like a message in a bottle from another star, a tiny piece of a different solar system, delivered right to our scientific doorstep. It's a huge deal. So in late 2025, it was showtime. The object made its closest approach to the sun, what we call its perihelion. This is the ultimate trial by fire, where the sun's intense heat and gravity just wreaks havoc. And you guessed it, what our telescopes saw during this flyby is what kicked off this whole massive controversy. Right away, there were clues that this wasn't just your standard issue space rock. But let's get right to the biggest, most mind-bending anomaly of them all. On November 9th, 2025, the images came in, and wow, they showed two absolutely colossal jets of gas and dust erupting from this thing. One was blasting towards the sun for 1 million kilometers, and the other streamed away from it for a staggering 3 million kilometers, just enormous. This is when Harvard astrophysicist Avi Loeb steps into the scene. He sees these giant jets and asks a pretty simple but critical question. Just how much stuff would need to be boiling off this object to create a light show this big? The number he came up with was just jaw-dropping. Roughly 5 billion tons of material were being blown off every single month. Now get this, the entire object was only estimated to be about 33 billion tons to begin with. It was like it was tearing itself apart at an incredible rate. And this led to what Loeb called the energy problem. See, for the sun to vaporize that much ice, the object needed a huge surface area to soak up the energy. We're talking over 1,600 square kilometers. But when they looked at it with the Hubble Space Telescope, its surface area was less than a quarter of that. The numbers just didn't add up. It was impossible. Loeb basically summed it all up with this perfect quote. The object was way, way too small to be producing jets that were that big. It was like seeing a tiny little matchstick giving off the heat of a forest fire. Something was seriously off. So this massive energy problem led to a really clear, really simple prediction. If this thing was a natural comet, there was pretty much only one way it could be pulling this off. The logic went something like this. Okay, a single solid object can't do it. But what if it wasn't a single object anymore? What if the sun's intense heat had finally done it in? The only natural explanation that made sense was that it had disintegrated. If it had shattered into tons of tiny little pieces, all that newly exposed surface area could, maybe, explain the massive jets. So that became the leading theory. 3I/Atlas had broken up, so everyone was waiting for the new, sharper images to come in after it passed the sun to confirm that, yep, it had shattered into a cloud of debris. But when those images finally arrived, the story took a hard left turn. On November 11th, 2025, astronomers David Jewett and Jane Liu published their findings, and the title of their report was as blunt as it gets. And with that, the breakup theory was completely, totally wrong. They used some amazing techniques to scan a huge area around the object. We're talking 500,000 kilometers wide, looking for any fragments at all. And what did they find? Absolutely nothing. Not a single piece. Despite everything, 3I/Atlas had flown around the sun and come out the other side perfectly intact. Well, this discovery just blew the doors off the whole debate. The breakup theory was dead. So now, scientists had an even bigger puzzle. How does a small, single object survive that trip and produce those impossible jets? So basically, two main camps form. On one side, you have scientists like Avi Loeb, who say, hey, if natural physics doesn't explain the jets, maybe they're not natural. Maybe they're technological, like thrusters. Then on the other side, you have most planetary scientists who are saying, hold on, let's not jump to aliens. It's probably just a very, very weird comet that we don't understand yet. So, okay, what are the natural explanations? Well, there are some pretty cool ideas. One is this concept of a cosmic ray crust that maybe billions of years floating in deep space formed a unique outer layer that reacts to sunlight in ways we've never seen. Or maybe our math is just wrong. Maybe the dust is super reflective, tricking us into thinking there's more of it than there really is. And there's a really simple argument, too. Why wouldn't it be weird? It's from another star. It's almost guaranteed to be different. And I think this quote just perfectly sums up how a lot of astronomers feel. Comets are chaotic. They're unpredictable. They surprise us all the time. So to say that some weird behavior must be unnatural is a really high bar to clear when these things are just fundamentally unpredictable to begin with. So the debate rages on, and the mystery is still out there, and it really shows this classic tension in science, right? Do you stick with what you know, even if it gets really complicated? Or when the data gets straining enough, do you start to consider some truly extraordinary possibilities? Which brings us right back to the beginning. After all of this, the observations, the math, the arguments, what on earth or what not on earth is this thing? And the honest answer is we still don't know for sure. But here's what I think is the most important part. Objects that break our models, the ones that don't fit, those are the most precious things in science. Whether 3I/Atlas is just a super weird comet or something more, its very existence is pushing us to rethink what's even possible out there. And that leaves us with one final incredible thought. This was only the third interstellar object we've ever spotted. As our telescopes get more powerful, we're going to find more of them. So you have to wonder, what other secrets, what other puzzles are out there right now, silently cruising between the stars, just waiting for us to find them?